All right. Good evening, everyone. Thanks for showing up. So I'm Mike Nikles, as you see on the slide. I didn't put a company name. Amin already explained that. I was showing these slides to my coworkers last week, and I didn't want to reveal too much before I officially announced my resignation. But yeah, I'm going to go join Google and basically do what I'm doing tonight as my full-time job. So this is kind of a dry run. And if that fails, hopefully nobody at Google sees that, and they still let me start next week. Yeah, please don't look. Okay, so I'm going to talk about Cloud Build. Before I get into that, does anybody know what Cloud Build is? Has anybody heard of Cloud Build other than Amin? Well, okay. What about Container Builder? Nope. Okay, that's just the previous word for it before Google Next. So I'm going to see what I can do here. All right, I want to talk about three things tonight. The first one is I want to explain what Cloud Build is. Clearly, that's making sure everybody's on the same page before we get too far. And then I want to explain why it matters. Why do you need Cloud Build, or why I recommend you to use Cloud Build. And I also want to show you how you use it. Otherwise, you leave the venue and you have no idea what to do. Now, I'm going to go further on. So what is Cloud Build? It is a tool or a service provided by the Google Cloud team that allows you to continuously build, test, and deploy your applications. Is anybody familiar with CircleCI, Jenkins, anything like that? All right, quite a few of you. So Cloud Build is something very similar where you can define your build steps. You can do a whole bunch of things, and eventually you build some image. Tonight we're going to focus on a Node.js application that we test, build, create a Docker image, ship it to a Docker registry, and then deploy that to Kubernetes. So in more detail, Cloud Build allows you to trigger builds for each commit. That's exactly the same thing as Jenkins, CircleCI, any of the other continuous integration, continuous deployment tools. Every time you do a git push and that code goes to GitHub, you can trigger a build on Cloud Build that does a git clone and whatnot, gets the source code, runs a bunch of steps that we're going to look at on how to define that. One thing that I really enjoy about Cloud Build, you can obviously run that in the cloud. It's an online service in GCP, Google Cloud Platform, where it just runs for you automatically. It does whatever you tell it to do. But if you've ever dealt with debugging one of your build files, like the Jenkins file, the CircleCI configuration file, you know that it's pretty difficult to figure out what's going wrong because you have to make a code change on your local computer, update your file, send it to the cloud, wait for the build to start, make sure it runs, maybe do an SSH into the box to make sure it's all okay. With Cloud Build, you get the benefit of running your builds locally. So if you make changes to your configuration file, you can run that locally, validate that everything's okay, push the code up, so you speed up that feedback loop significantly. You can run tests, unit and integration tests. I could imagine that there's a way to run end-to-end tests. We just haven't done that at Rival Technologies. But there are tools that allow you to use Docker Compose, and you could fire up a bunch of instances, run your end-to-end test against it, and shut it down. And lastly, as I mentioned, you can deploy. I mentioned a bunch of Google Cloud services, but you could deploy really anywhere you want. Before we were on Google Cloud, we used Cloud Build to deploy to other cloud providers as well. So that works as well. Any questions on what Cloud Build is so far? Okay, cool. Now, why does it matter? I asked myself the same question when I was migrating from another provider to GCP, and a couple of things. Speed is important when you build something. You want to get that instant feedback, ideally instant feedback of how is my software doing? Is it running perfectly? Do I have my bugs all fixed? Are my tests building or passing? So Cloud Build leverages high CPU VMs, Cloud Engine, Cloud Compute Engine on the Google Cloud Platform, so you don't have to worry about running out of memory or things like that, generally speaking. You can do things like caching. You can run builds in parallel. So if you have a number of developers that almost like at the same time do a git push, you could have multiple build runs in parallel. And another thing that I'm going to go into more detail that was a big factor for us is the minimal internet data transfer. And I'm going to explain what that means with a diagram that's much more clearly to understand. The next is role-based access control. So we used different tools before, and we had a hard time limiting who is able to push builds. And we don't want everybody in the company to run production builds, at least back at that time. With Cloud Build, you can specify exactly who is allowed to build, who is allowed to view the builds, who is allowed to deploy. There's configuration for all of that, and you can manage that through the Cloud Console or through configuration files as well. In terms of cost, any of these online providers, they have some kind of free tier that allows you to run on Google Cloud. Cloud Build, you get 120 free build minutes per day. So that's 2 hours where your builds are running and building. Now, if you make sure that these builds are going fast, you can actually do quite a lot on the 2 hours that you get for free per day. In fact, our stuff still runs on the less than 120 minutes per day. You can run up to 10 concurrent builds. So if 10 developers at the same time do a git push, they all run in parallel, and you don't have to wait for anybody else to kind of complete their build first. And another nice benefit is you don't pay when your build is in queue. So if you have more than 10 running at a time and 2 or 3 are waiting in a queue, you wouldn't pay extra for that. I mentioned the local debug before. This is a really big thing. In our case, it saved us so much time. Then every time we migrated from like a monolith to many microservices, and we had a lot of build issues. We had to go back many times to tweak it, add new scripts and new build steps, and being able to run that locally and getting that feedback almost instantly before we do even the git push was really a huge time saver for us. Okay, so we're going to look at 2 scenarios. One is a continuous integration, a continuous deployment setup without Cloud Build. And then on the next slide, I'm going to show you one that indicates how it works with Cloud Build. Now, before I get started, who is currently doing some kind of continuous integration or continuous deployment? Raise your hands. Okay, I'm curious, what kind of tools do you guys use right now? Anybody? CircleCI. Jenkins and CircleCI. Okay, perfect. Give me some numbers on how long it takes from the time you do a git push until you can go to your environment and look at the change in the browser if you have a web application, for example. Like the whole flow of like git push to fully deployed.
6 to 10 minutes.
6 to 10 minutes. Can anybody top that? Up or down, doesn't matter. 5? That's a lie. Oh, they're small apps, fair enough. Any other numbers? Okay, I think we did something wrong. We were at about 12 to 15 minutes for a big app, so I guess that's the caveat. Okay, so let's look at that, and if there are any questions along the way, just raise your hand and ask anytime. So we have a developer at the top. She does a git push, and the code gets pushed to GitHub or GitLab or wherever you have your source code stored. Now, before we go further, you notice the cloud up there. So every time you see a cloud on the slide, it means that some kind of data is going over the public internet. Okay, so in this case, your developer on your local machine does a git push, and that sends the source code up to GitHub over the public internet. Now, the color indicates that there's like the load of the data, the size of the data is kind of so-so, right? A bit of source code isn't really heavy, it doesn't really take too long. So once the code is on GitHub, GitHub does 2 things. Well, GitHub does one thing. It notifies your CI/CD system that there's a new commit. That's the green cloud in the back. Green means it's just like a notification, maybe a few kilobytes of data that's being sent over the internet. The reason why I'm mentioning these different colors is green obviously means that there's a very short time delay to send that data. Orange means it's a little bit bigger, takes a little bit longer. So once GitHub notifies your CI/CD system, your service is doing a git clone to fetch that latest code from your GitHub repository. Does that make sense so far? Okay, lots of nodding. Now, what happens next in like a general scenario is the CI/CD system runs some tests, it does some building, maybe Docker build, and Docker push. And in our case, we used the public Docker registry on I think hub.docker.com, whatever. Now, you notice that there's a red cloud. Red means, holy smokes, we don't know how to do that, because we send like an entire image that could be a couple hundred megabytes from the CI/CD system, which lives somewhere on the cloud, to the Docker registry, which lives somewhere else. So that takes a certain amount of time. It's fairly slow in comparison to everything else that's going on. Now, when that image was pushed to the registry, we somehow have to tell our application servers that there is a new image available. We want to deploy that now. So to simplify things, there's some kind of notification going to our app servers, whether that's some script or whatever it is. It notifies the app servers. The app servers then go to the container registry and pull that image down onto their servers. Again, a red cloud on number 6 there, which means we have to now go fetch that image we just uploaded down onto the application server. Again, going over the public internet, it's fairly slow. Once that's there and the servers are started, the image has been replaced, the new version is live, your CI/CD system sends a notification to the developer, whether that's a Slack notification or a browser pop-up or whatever you have configured, letting them know that, hey, there's a new version of the app available, and they can go check it out. So we heard before that this kind of process takes anywhere from like 5 to 13, 14 minutes. Any questions on that? Does that look familiar? Has anybody set up something similar to that? Okay, yeah. It's fairly standard, I think. There's certain things we can optimize. Now, what I want to show you is where Cloud Build comes in and really speeds things up and makes things much more easy to manage. Because here, we're managing a CI/CD system, a container registry, a whole bunch of things we have to do. With Cloud Build, things look a little bit different. The start is obviously the same. We do some git commit, git push. We send the code somewhere. That triggers a notification to Cloud Build. So Cloud Build gets notified saying like, hey, a new commit is available. It fetches that code, same as in the previous slide. Now, when you create slides, don't use like light gray as a background. There should be some kind of box down here. Anyway, showing Google Cloud Platform. So now what happens, instead of sending, once the Cloud Build runs the tests and builds the Docker image, we still do a Docker push, but instead of pushing that to the public registry from Docker, we send it to the container registry, which is a very similar service that just hosts container images, Docker container images. We send it there. Now that, you notice there's no cloud in between. That means we're actually sending that in the Google internal network from Cloud Build to the Docker, the container registry. So that's much faster than sending it over the public internet to another service. The flow is exactly the same. In our case, we have Kubernetes engine. So we notify Kubernetes engine saying like, hey, there's a new image available. And then again, Kubernetes gets that new image to the deployment. It updates that and releases the new version. Step 4, 5, and 6 are all internal. They never go over the public internet, which speeds things up. It's also much more secure. Your data is not going over, the public internet to different services. The remaining 2 steps are the same. We notify the developer goes checks the website. Now, once we migrated to that, we went from about 13 to 15 minutes. We cut that about in half by simply just avoiding the multiple steps over the internet of sending data back and forth. And also Cloud Build actually built our stuff faster than we had on the previous system. Any questions on that new approach, on a new slide? The flow is exactly the same. There's 8 steps. It's just that a majority of the data is now handled in an internal network, which is much faster than the other one. Okay. Now, in order to set that up, it's actually much simpler than you may imagine. So I'm going to go through 3 examples. I went online and I searched for documentation about Jenkins, CircleCI, and then Cloud Build. So people who use Jenkins, you might be familiar with something like that. That's copied straight off from the documentation. We have 3 stages: a build, a test, and a deploy. That's kind of like fairly standard when you have any kind of application. That's the amount of kind of code to just print, echo, whatever, what's happening. There would be more code, obviously, if you were to actually run any tests or build a Docker image. For CircleCI, again, that's copied from their documentation. It's a little bit different, and I actually simplified that as well. We only have one default build step. If we wanted to use their workflow feature, we would have to add a whole bunch of other code to configure that and make sure they run after each other and whatnot. Now, what's obviously most interesting is doing the same thing on Cloud Build. Cloud Build also uses YAML for the configuration file. And what you see here is basically just a list of steps. All you need to do is just tell Cloud Build, hey, step 1, use the Ubuntu Docker image, and then run the echo command, and this is the argument that I'm passing to echo. So it kind of stay the same example as I had before. Now, what's really interesting is that with Cloud Build, each of your steps, you can use a different cloud image or a different Docker image. So if you want to do, in this case, we just fire up a Ubuntu Docker image, we run echo on it, but the name that you see here, we can change that to any public Docker image. So you could even write your own Docker image, publish that, and then use that here. I'm going to show you how that works. First of all, these, can I go back as well? Yeah. So every step, that name property there is specifying which cloud builder that you want to use. A cloud builder is a container that executes a build step. And there's 3 categories of cloud builders that are available. The first one is provided by the Cloud Build team, and you notice that they start with gcr.io, and then you have Docker, you have Go, you have NPM. There's a whole bunch of them. And once I publish my slides, you can click the link there, and it'll bring you to the GitHub repo where they're all publicly hosted. You can do Yarn and NPM, things like that. Then the second category is provided by the community. So that's anybody who built something that's reusable by other people. So for example, Docker Compose and Hugo, if you want to do a static site. You can also use these cloud builders to execute steps in your pipeline. And lastly, there's a way to write your custom steps. So if you have some kind of OS libraries that need to be installed on your system in order to build your application, you could build your own custom image and then use that as a custom step when you go through and run your cloud build process. Yeah, I actually already talked about that, the building it locally. And what I want to show you is just the fact that getting Cloud Build to run on your local environment, you need G Cloud installed. If you work with Google Cloud, then you probably already have that. But once you do, you can install Cloud Build Local with that command right there, and then you literally just run Cloud Build Local in the root directory of your application, and it builds your application on your local machine, giving you all the feedback that you will eventually get when you deploy to production. All right, so I was wondering just how much effort it would be to actually build a configuration file for Cloud Build that installs some NPM dependency or some node dependency, and then runs a bunch of tests, runs a build step, and then deploys that to a Kubernetes cluster. And I put that together in a couple different steps. So in order to install the dependencies, you can see that we use the NPM Cloud Builder, and then we give it the argument install. What that does is it literally runs NPM install as the first step. Now, from one step to another, it keeps track of what you did in the previous step, so you can install the dependencies, move on to the next steps, and then leverage that and continue on. Once we install the dependencies, we use the NPM Cloud Builder again, and now we are giving it the argument test, which results in NPM test being run against your source code. If any of these steps fail and return a non-zero exit code, then you would get a failure notification saying it blew up, you have to go fix something. The third step is we want to build that Docker image. So now we are using a Docker Cloud Builder. What that means is that we have now access to the Docker command line interface. So in this case, we do, that translates to Docker and then build and then all the arguments afterwards. This is just building an image that belongs to my project. It's called my image, and the tag is the current revision ID that I get from GitHub, the current SHA commit. The second step in the build process is, again, a Docker image where we do a Docker push, and now we're pushing that to the container registry, as I showed on the previous image. Lastly, we use another cloud builder right here, and now we are setting the image for my deployment. Give it the container down here, and that's the same string as I used in the previous example to build it. And with that in place, we have a full end-to-end continuous deployment setup for a very basic NPM or like a basic Node.js application. All together on one slide, it just barely fits. Barely fits. It's 5 or 6 steps that you put in your cloud configuration file, and then you're good to go. You can put it at the root of your project, commit it, set up your trigger for the git commit, and you're basically good to go to deploy to your Kubernetes cluster. There's obviously some work to set that up in the beginning, the cluster itself and whatnot, but that's all that we currently have in our configuration file. Cool. With that, are there any questions on generally cloud build, anything I showed related to your project maybe or overall? Yeah.
On the previous slide, I'm wondering, what is this? What are the commands that can run on local from this? Because if you run push on local, then you're gonna push that image through the internet. So I'm wondering, when you run Google Bit local, what part of this is can you run local?
Yeah, that's a good question. I think it actually runs the whole thing. So yeah, that's a good question. I have to look that up.
So if you push, it would actually go through and push.
It would override. Yeah, I need to look that up. I think, so the way we run it, the way we avoid going to production when we run it locally, we have different setups on our local computers that point to development environment. And what we use here instead of strings, there's something called substitutions where we have variables that replace the values. So it wouldn't actually go to production, but because it's hard-coded here, that's famously. It still goes to the internet, I believe, to the container registry, but to a different project, my project -dev, for example.
Yeah. Does it support Kubernetes Helm?
Second?
Does it support Kubernetes Helm?
I believe there's a community builder, cloud builder for Helm, I think. Yeah. Oh, the question was if Cloud Build supports Helm for Kubernetes. I thought I read about it. Yeah. Any other questions? Cool. Yeah, thanks very much.
Thank you.
Yeah, what's the question?
So, have you used it with App Engine to deploy to App Engine with G Cloud? Like, can you run G Cloud command to deploy to App?
Yeah, there's a cloud builder for G Cloud as well, and you can run that. So it's App Engine. If you have Firebase, you can deploy Firebase. We use a number of cool cloud functions for some of the processes that kick off. That is also using the same configuration file.
Have you used App Engine? Because one of the issues that we have with App Engine is that the build time to build the images from Jenkins is very long. It's like brutally long.
To be honest, the only App Engine service we have is the default one, just so that we can actually use App Engine. We don't deploy any of the services anymore. But now, App Engine now actually supports Node 8 in the standard environment. So this is something we're reevaluating to go back and maybe move some of the stuff back to App Engine. So, cool, thanks. Oh, yeah.
So how do they charge you based on running time of the build?
Yeah, once you exceed the 2 hours build time per day, then it's going to charge you whatever fraction of $1 for every additional minute that you run it. Yeah. And then at midnight it resets to the 2-hour counter back to 0, and you have another 2 hours for free. Yeah. So this is a good incentive to speed up your builds and make sure they're fast. It also helps with feedback loop. Cool. All right, thanks.